Okay, here we go. Unit 2, Lesson 3, Simplifying Variable Expressions. So we can identify parts of a variable expression, and we can identify algebraic expressions. So we've got a lot of vocab in this. So let's take a look. So a term is each individual unit or each individual section of an equation. So it's a term in math is kind of like each individual section. So let me give you an example, because again, I think examples in math are always super important. So if we look at the example 2x plus 3, I see that I have 2 terms. So this would be 2 terms. Whereas let's say I had 4x squared plus 5x minus 3. In this example, I have 1, 2, 3 terms. And so you can kind of see that, hey, the terms are separated by some type of sign, whether it's an addition, a subtraction, multiplication, division, okay? It's separated by an operation. So again, that could be any type of, could be parentheses, could be multiplication, addition, subtraction. A constant is a number that never changes, okay? It's a number that never changes. And a constant does not have a variable. So for example, 7 is a constant, or -5 is a constant. There's nothing else attached to it. That 7 is always going to be 7. That -5 is always going to be -5. Now, like terms are 2 or more terms that can be combined. So they have something in common. So let's do an example. I'm going to take our like terms example, and I'm going to move it right here. Okay, so example. So an example of a like terms would be like if I use 2 constants. So what did we say? 7 and -5. So if I use that same example and I say 7 plus -5, I can combine these because they are like terms, and I would say, well, that answers 2. Another example, let's say I have 7x plus -2 or -5x. Okay, because both of these terms have this same x, we can combine them because they are like terms and get an answer of 2x. However, if it's got an exponent, so let's say 7x squared plus -5x, these are not the same, okay? These are not like terms because of that exponent. Not like terms, okay? So that exponent of x squared changes it. So because that's really x times x. X squared is x times x. So these 7x squared and -5x are not like terms, and we cannot combine them. You can only combine terms that are the same, like terms. And the coefficient is the number, okay, the number in front of a variable. So again, you'll hear me say that we are, like when we have like terms, like right here, the coefficient was 7 and -5. So I'll do an example. So if I have 7x, the coefficient is 7. If I had -5x squared, the coefficient is -5. So all the coefficient is the number that's in front of your variable. Now again, I know that's a lot of kind of vocab. But we have to be able to communicate with one another. So again, when I say the word term, I want you to think, okay, it's an individual section that's separated by some type of operation, whether that's plus or minus. Coefficients, we're going to add our coefficients, or we're going to divide our coefficients. So again, those are words you're going to hear me start saying. So identifying parts of an expression, name the coefficients, like terms, and constants in the following expression. All right, so my constants are numbers that never change and they do not have a variable. So I only see one number that does not have a variable, and that's -4. My like terms are numbers that have the same variables. So again, make sure you include that negative. So I see a -2n and a +n. So my like terms are -2n and +n. And then my coefficients are the numbers in front of my variables. So I see I've got a 3, I see I've got a -2, and remember our multiplicative identity. If there's no number in front of our variable, that's like saying 1 times n. So I would say that my coefficient is a 3, a -2, and a +1. Because 1 times anything equals itself. So again, how does this kind of work? If we use Algebra Tiles, this is a PDF, I can't move them around, but we can kind of look at it and say, okay, I have 2x, so 1, 2. I've got 4, which is different, okay? These are different, so I might not be able to combine them. And then I have 3x again. So 3x again, here's 1, 2, 3. So as I combine them, so I'm going to say I've got 1, 2, 3, 4, 5, and then I still have my 4 on the side. So again, I would look at this and I would say, hey, I'm going to add my coefficients. 2x plus 3x is 5x. I can't do anything with that one yet. So I would just say plus 4. 5x plus 4. I am combining like terms. All right, remember, if there's no number, if you don't see a number in front of your variable, you assume it's a 1. So yes, these both have a y, so I can go ahead and add them. 5y plus 1y is 6y. Again, assume if there's no number, it's a 1. 1 times b equals b. So again, 1 times y equals y. 1 times b equals b. I'm not changing it. 3b, subtract 1b equals 2b. 2b or not 2b? That is the question. -4m, subtract 9m. So remember, when I subtract these numbers, I have to actually add the opposite. That's our rule when we are subtracting a negative number like that. So I look and I say, hey, they both have m's, just like these both had b's and letter A both had y's. So -4, I'm going to add my coefficients. -4 plus -9 is -13m. Once again, assuming that I have a 1 here and I see I've got a p, and a p, I'm going to just start on the left and say 1 plus 6 is 7p, and 7p subtract 4p, 7 minus 4 equals 3p. Okay, our last example is going to be simplifying a little more complicated expression. And again, it says justify each step. First thing I need to do is I look inside my parentheses and I don't know what g is, so I can't do anything inside parentheses, but I can use the distributive property. And that means to multiply each term, two terms inside my parentheses by this number outside. So 4g stays the same, plus 3 times 3 is 9, 3 times g is 3g. And that's the distributive property. So again, the word justify means explain everything. Now, my next step is to look and say, do I have any like terms? And I do. I see I've got a g here and a g here. So I'm going to add the coefficients. The coefficient, if you remember, is the number in front of your variable. 4g plus 3g is 7g. And again, that is combine like terms. Now, I don't know what g is, so I can't simplify it any further. So that's going to be my final answer, because until I know what g is, I can't do anything else.